All right, so the last two videos we did had to do with volumes of pyramids. And now we're going to look at pyramids who are similar. Okay, so one way to think about similarity is that there's some scale factor, right, that would apply to the dimensions of the object, in this case, a solid pyramid. All right, so that's how we're going to approach this problem in terms of scale factors. All right, so square pyramid A and square pyramid B are similar. Okay, so that means that there's some scale factor that ties all their dimensions together. All right, the height of pyramid A is 6 inches and the height of pyramid B is 15 inches. Okay, so I'm going to go ahead and zoom out here. All right, just make a chart. Okay, so pyramid A, pyramid B. Okay, and then the height is 6 inches for pyramid A and 15 inches for pyramid B. Okay, and then the volume of pyramid B is 312.5 cubic inches. Find the volume of pyramid A. Okay. All right, so here's the deal, right? Height was measured in inches, right? It's a one-dimensional measurement. Okay. Volume was measured in inches, inches cubed, cubic inches, right? It's a three-dimensional object measurement, okay? And we could just throw an area as well. Area would be measured, in this case, in inches squared because it's a two-dimensional object, okay? So when we go from height to area to volume, we're increasing the dimension each time. Okay. All right, so the scale factor, right, will increase with the dimensions, right? So, let's write X here, right, which is going to represent the volume of pyramid A. So we can figure out the scale factor, which I'll call K, between the heights, right, the one-dimensional measurements of pyramids A and B, okay? And then for area, right, the scale factor would be would apply twice, right? So we'd have K squared as a scale factor since area is a two-dimensional object. Okay, so then when we hit volume, right, now the scale factor is going to be cubed because of the three dimensions, right? So there's, one factor of the scale factor for height because it's one-dimensional. There's two factors of the scale factor for area. There's going to be three factors of the scale factor for volume. Okay. All right, so let's find what the linear scale factor is, right? The one-dimensional scale factor. Okay. So we can create an equation, 6 times K equals 15, right? That's what I get from this diagram. 6 times K produces 15. So write it as an equation. All right, divide both sides by 6, and you would get 2.5. Right, so our scale factor K is 2.5. Okay. So over here, right, this schematic says X, the volume of pyramid A, times K to the third power equals 312.5. So let's write that as an equation now. So X times K to the third power equals 312.5. But we already know the value of K, so we can substitute that into our equation. So now we have X times 2.5 to the third power equals 312.5. And now all you have to do is simply divide both sides by 2.5 to the third power. Okay, so it'll cancel on the left-hand side, and then that will should give you the final answer, right? So 312.5 divided by 2.5 to the third power. Here we go. 312.5, 2.5 to the third power, okay. So X is 20. Okay, so X, which is the volume of pyramid A, is going to be 20, and then the units are inches cubed, since volume is a three-dimensional object.